We'll let him present himself and more about what's doing these days.
First, thank you, Daniel, for having us here again. I've been to many of the events already. Thank you, Pascom, for all the support and recording everybody. Thank you, David, for helping me with a laptop today. And I would like to also give a special thank you to the hotel for having the same AAA batteries in the TV remotes as I need in my presenter. So I'm the founder of Zoiper, or one of the co-founders of Zoiper, like 20 years ago. That's how you might know me. But nowadays, aside from managing Zoiper, I also make pipelines for speech-to-text training, a little bit of text-to-speech training. I'm not really a machine learning engineer. I just play with lots of Python scripts and a lot of ChatGPT. Today, I'm going to try to go very briefly through the latest advances in local on-premise ASR solutions. I don't think I'll get to any text-to-speech models because there simply won't be enough time. I'll talk a bit about what we do in Vanheuverzwijn and the Kroko models we have. And then I'll try to explain the challenges of comparing different speech-to-text solutions because it's actually not that simple. And then maybe at the end, some fun with Whisper, some things we discovered when benchmarking our own solution against Whisper. So at Vanheuverzwijn, we make meeting transcripts. It looks like this. It's kind of, we take audio from different PBXs, from a soft phone, from a browser extension where you have a Zoom meeting running or a Jitsi meeting running. And then we use VLLM to process this transcript, do emotion analysis, make summaries, action point extraction, tagging, compliance, classification, the usual stuff, nothing special there. So second part. Quickly, well, we'll go very quickly through the models, the new ones, and let's say last year. Maybe I'll only talk about the next generation. So you might have seen that large language models, some of them start to be multimodal. There's 3 open source ones that I know of. I played a bit with some of them, and I wanted to mostly mention them because they advertise or say certain things about the accuracy they have. And I think it's not really a fair number because they are using data sets that they trained on the text for first. Because it's Wikipedia, it's Project Gutenberg. They obviously know already what the transcript looks like before they train the audio. Maybe a bit quickly about the current generation. So SenseVoice is a Chinese model, I think, that they have 2 versions, a large one and a small one. Only the small one they released. The large one supposedly does something like 100 plus models, languages, just like Whisper does. The small one only does English and a few Asian languages. But it also has audio classification, some other, like it could probably tell you that the dog is barking in the background. There is not a lot of news in Whisper as they seem to have gone commercial now. But still you have Whisper Turbo, which I think is for slightly more than a year ago, which is just a bit faster at the expense of a little bit of the quality. There's some distillations that are really good just to make it faster. There are a couple of good language-specific fine-tunes available from like big organizations. You'll find zillions of fine-tunes made by some guy at home, mostly fine-tuning on Common Voice. Those are usually, they look good when you look at the test set for Common Voice, but for anything else, they're kind of useless, and I'll talk about this later in the presentation. NVIDIA Canary released a multilingual model about a month ago. I tested it. It's quite good for English. It has a bit too many deletions, but overall it's quite good. It also does English, Spanish, and German. Spanish, German, and French. Those are not as good, and I think Whisper probably has better results there. Moonshine is a very small model, English only, that is good for on-device. It also does streaming. It's a bit similar to what we do. Then this is OWSM is Open Whisper style model. I only discovered this yesterday, so I can't tell you much about it. And then these are the models we made as part of Vanheuverzwijn, and some of these models, I'll skip all of this because there's a new one tomorrow anyway. Let's talk a bit about Kroko ASR. So this is the result of the training we did. They're built on ZipFormer, which is a project from the K2 Icefall guys. On the next slide, I give a link where you can download and play with them from Hugging Face. We made some plugins available on GitHub for Asterisk and FreeSwitch and a few more. And it's very small, it's very fast, and I think the quality is pretty good. So it's 10 times real time on a single CPU core, which means that the demo on the next slide you will be able to just play here live. So take out your phone already, scan the QR code, play with it. And we'll also be also fine-tune Whisper Canary for some of the benchmarks we do. So if you ever need something like this, let us know. Let's see if I can actually show this. So this code, if you can scan it, you can play with it on your mobile phone. This will launch a WebAssembly in the browser, and it can give you an idea of what quality we can achieve. Nope. Let's see if this works here with this setup. Nope. Ah, nee, I clicked on stop. Is this doing something now? Does it work? Yes. So this is just gives you an idea of what you can run locally on your mobile phone. I think our commercial models are a bit better and have a bit lower latency, like half the latency. And this you can get either on the QR code or just for Kroko streaming ASR. I'll go back to the slide. So the commercial models are just a bit better and a bit faster in terms of latency. And we also have offline, open source, we didn't, or open weights, we didn't release any offline models. It's 30 times faster than Whisper v3 on CPU. So how good are they? If we're 30 times faster than Whisper v3, are we also better? Or we just have horrible quality? So some of the websites, cloud providers advertise, oh, we have an accuracy of 95%. Well, that's brilliant, but it doesn't say anything. Unless you know what is tested on. Is this noisy call center data? Is this kids? You don't know it without knowing the data set. So this brings us to the next part. How do you actually compare different providers, different models? So this is a comparison of the word error rate between our, I think this is the commercial models and the Whisper part. So we can say that on the word error rate for Common Voice 20, we have relative 22% less errors. But I'll explain a bit more so quickly. What is this word error rate? This is the sum of the insertions, deletions, and substitutions after aligning them with something like fastware or jware. And then you divide it by the number of words in your set, and this gives you the word error rate. But it doesn't really work that easily. First, you need to normalize. If you don't normalize, then you have enormous word error rates, because these things should have an error rate of 0, because they mean the same. But you need to get rid of I'll put it here. So you need to lowercase, you need to remove punctuation, you need to normalize the numbers. You might need to deal with the German spelling that changed in the moments they made the data set and today. And there's some specifics for different languages, like in Arabic and Hebrew, you need to remove some sort of diacritics for this. And then you'll end up. So since we normalized, and there's one thing more. In English, the easiest thing to do is to go to the Whisper sources, and for English, there's normalization built in. So this one you could easily do. So since we have a lower word error rate, does that mean we have better models? Not really. Whisper is using a Common Voice test sets to compare or to show what quality they have and how Whisper 3 is better than Whisper 2, for example, how they evolved. But Common Voice is a bit of a tricky data set. It's made by volunteers reading texts that are mostly from Wikipedia or Gutenberg, which means it's non-conversational. And most of those volunteers are non-native speakers, or many of them. I think they use them in language courses or so. So after they make these recordings, another volunteer has to say if this is correct or not. But because of the type of data set and because of the way they record it, it is very limited in domain. Like, it's not like it's financial data, it's not call center audio, it's not even people having normal conversation. It's just people reading audio. And it's always short form, less than 20 seconds. I won't have much time to go into the specifics for why long form is harder than short form. Sorry. So let's go a bit more. So it doesn't say the WER score on Common Voice doesn't necessarily mean that you will have similar results in other data sets. If you have multiple speakers, will it get it? Will it not get it? Common Voice is not going to tell you. If this audio is very noisy or has been through GSM compression, you don't know as well. And you also don't know how good, this is a very important one, how close this transcript is going to be to reality. Because in the common voice data set, the test set, there's a lot of people stuttering or disfluencies or saying the same thing 3 times. And many models will try to correct that, which is in some cases a good thing, but in other cases not a good thing. So this is a very important one. It's not because your WER is higher that it's a worse model, it might be a better model. And there's another problem with it. It favors certain scenarios.
But how, O pious lady, say, may we thy gracious boon repay?
This is actually not common voice, it's LibriSpeech, which is a common data set for testing for English. They train on people reading old books and old poems. So if you train on common voice, on LibriSpeech, you will probably have a very good score at doing this. If you train only on conversational data, you will not be able to get this phrase. I probably need some volunteers for the next one. Any native French speakers here? Okay. Can you tell us what this phrase reads?
La gmina est bordée par les gminy de Nielisz, Radecina, Rudnik, Szebrzeszyn et Turobin.
I'll play it again.
Didn't sound very French.
La gmina est bordée par les gminy de Nielisz, Radecina, Rudnik, Szebrzeszyn
Could
et
you spell
Turobin.
it for us, please?
There are point words inside.
Exactly. So this is common voice and some of the limitations that they have. So this is, I searched for the phrase, I found it immediately in Wikipedia. So this is considered French test set. It's not going to help you really with people speaking French. And but if you have, like the speech LLMs, the new ones like Q and Audio and these things, they will probably get it correct because they know this phrase, because they train text on Wikipedia. Well, they trained also on the rest of the internet, but this will also be there. But also, if you have a model that was trained on common voice, there's overlap with the speakers, but there's also overlap with some of the text. So probably some of these words will be in one of the train set samples, and you'll have a better result. So you need to kind of keep this in mind. Whisper, as far as I know, is not trained on common voice. So they won't have this. So if training on common voice makes the WER score on the test set to compare with Whisper better, why didn't we do it? Garbage in, garbage out. We used to train on it for 3 years, and then when we started doing streaming models, we saw lots of deletions where you say something and 3 earlier words suddenly changes something, deletes something. A big part of it came because of common voice. I think in common voice dataset, there's several percent that is wrong.
Eh bien, point d'exclamation. Donne-moi la main, virgule, mon vieux, point.
This, unfortunately, it's again in French. I don't have a similar example in English. This is what I want to say, that the verbatim way of putting a transcript is not always there. So in this case, the French sample that they pronounce contains also spoken punctuation. But the reference does not. There it's just text. And this is something that if you need to make a model that does dictation for a doctor or so, this might give you problems. Because it will try to remove them, it will try to actually put them properly, but not all your data will be doing this. So in the end, you don't know if it will put a point or not. So if you try to do something like this with Whisper, you will see that sometimes it will pronounce the thing, sometimes not. If you get rid of all of them, then if you say, oh, you really have a point there, and it puts a dot, it's also not a good solution. Oh, this is it.
I just shitted and farted all over myself. I just shitted and farted all over.
This is an actual recording from the test set, and this is the transcript. I know you couldn't hear it very well.
Eh bien, point d'exclamation.
I just shitted and farted all over myself.
I found it very funny when I saw
I
it.
just
So
shitted and farted
I had to play it.
Barimun including Popintri, Kimore, Kolok,
So I need native English speakers
Barak,
to...
and Monak Nemende. Barimun including Popintri, Kimore, Kolok, Edinburgh, Barak, and Monak Nemende.
So then, what did he say?
I've been working something, nothing.
Okay. So this is the actual
including
transcript. for this one.
Popintri, Kimore, Kolok, Edinburgh, Barak, and Monak Nemende.
So if you train on things like this, you'll end up with weird results. Okay, let's do one more, last one.
Beth Past is a Russian popular scholar, critic, and fiction writer. Past is a Russian popular scholar, critic, and fiction writer.
So at the moment, I think like for LibriSpeech, the word error rate, the record is like 1.6. But I know LibriSpeech also has Latin parts, has some things like this. So I have some questions on how viable it is. Because at some point, the error rate is already so low that to go from 1.6 to 1.55, you know, it's 2 characters probably. So if you want to make a test to compare different models, you have to normalize it. But I think you should make your own set with in-domain data. Like if you do medical, make something medical. Make sure it's 100% accurate, and that you have long form, and that there's different acoustics, different noises, different. So this should solve the problem, right? And now you have reliable where, and you can compare. Just one model gives you a certain word error rate, the other one is lower, so it's better. No, because the mistakes are not all the same. If you have a spelling mistake, maybe it's not so bad. If you process it with an LLM afterwards, it doesn't matter. If you have a deleted word, well, if this was the main word in the phrase, then an entity, for example, then it might be problematic. If it was just a stop word that was removed, then it's fine. And if it's a complete sentence, well, then the data is missing and your LLM will not bring it back. For an insertion, if it's a stuttering, a disfluency, something similar, it's not that bad. There's lots of words you can just omit. But some of them are dangerous. And one of the hallucinations that Whisper likes to do, if it's a very short segment, like in the case of a voice bot, and maybe there's only silence inside, Whisper likes to say, okay, thank you. So if the text-to-speech is asking, oh, I'm sorry, you sure you want to renew your contract for another year? There's no sound on the other side. The speech-to-text recognizes, okay, thank you. And then says, okay, I signed you up for a contract for another year. And there's reorderings, which Whisper does a lot. And so Whisper gets a slightly lower word error rate because Whisper likes to fix your grammar and change the words around in the order of the words and maybe use a synonym for a word that you didn't say. So to solve this, there are some proposals to use semantic error rate or semantic distance, which is some embedding thing. I didn't look into too much because you have to do it separately for every language. Again, it makes things a bit harder. So what is the best model? It depends on your needs. If you do subtitles, you probably want good punctuation. You want good spelling. If you have a voice bot, and there's other things like latency that play in the mind, come into play. So let's have a quick look at some funky things we found using Whisper. So what do we use Whisper for? We use it to check if we don't make some obvious mistakes. Like we forget the first words, the last words, we have issues with certain sounds. So we decoded thousands of hours, and then we sorted them by word error rate difference between Whisper and our solution. What did we find? That in a significant percentage of the recordings, Whisper automatic language detection is giving you or is detecting the mother tongue of the speaker and not what the speaker is actually using. And we found out this with an actual recording from in the office where I was speaking with my Bulgarian colleagues. Nobody said a word in Bulgarian, but Whisper did the automatic language detection on the first 30 seconds, which was a Bulgarian guy with a little bit Bulgarian accent in English probably. And so everything was translated to Bulgarian. There is a lot of deletions happening. I think this is happening on accented audio a lot, and with some accents more than others, so you can play with it a bit. There's quite a lot of deletions with Whisper where it just refuses to find something. And this is maybe made worse by solutions like Whisper X that are using Celero or another voice activity detection to get rid of hallucinations, which will be in one of the next slides. And so when you remove those hallucinations, when you remove the audio, sometimes Celero also makes a mistake because it was too quiet or it was too noisy. Celero decides it's non-voice, and if you don't give it to Whisper, then obviously you will not have the text either. Also, I have a couple more minutes, I think, yes. Also, when you have long form, Speech-to-text has two main ways of doing long form. Most of the models deal with something like 30 seconds at a go. So in the case of Whisper, there's and Canary and our things, there's two solutions you can have. Either you cut on silence with silence detection, and every time it's less than 30 seconds, or you do a sliding window and you try to, you take 15 seconds or so, an overlap, and then you try to stitch them back together. Usually the timestamps are not super accurate, but you will have some, and in the beginning, the head and the tail of the phrase, of the decoded 30 seconds, is the least accurate. So you try to overlap, and so that you try to always be in the middle of the best segment. But when you recombine those, you can't rely on the first part or on the last part from the other section, because you might have words that are cut in two, and then you will not have a proper transcript. So you need to find an overlap of correct words within a certain time span, and then you can recombine them, which may give problems if you have just on that moment somebody says a telephone number or another number 0000. The overlap might not know which zero is exactly overlapping, and you might lose one or you might have an extra one. So this is where some of the extra deletions come from. Anybody here used Whisper before, I guess? Have you noticed hallucinations like this one? The first one? This one is very common, but it's easy to fix, right? Either you use voice activity detection, and if there's still something passing, you look for n-gram repetition that you configure to say, and usually it will catch it, and you can decode with something else, change it a bit, fix it. Okay, thank you, I already mentioned. But there's other things as well. Sometimes you might see copyright C, some company, doesn't have anything to do with the thing you decoded. But, or it will suddenly think that there's a name. It figures out who said this, Jonathan. But there's no such person. So the red part is what is hallucinated. So in this case, the first one, a Beijing-based think tank Center for China and Globalization, said this in its report. And then Whisper decides to give its opinion. There is no doubt that the CCP is trying to make the world a better place for the Chinese people. Or this about the presenter yesterday, Christian. God really, really, really wants you to be a Christian and give a Willy presentation at Kamailio World. Another one, the federal government. The federal government is not going to be able to do anything. This is all Whisper.
But that's not hallucination.
This is hallucination. No, this one is true, yes. So it's interesting that here it's also hallucinating it in capital letters. And there's two more, it's very religious, ChatGPT. And here it's interesting as well for the last one, where it starts to say the full Our Father. So you see that n-gram detection would have detected a part of it, but not all of it. But also it suddenly says that it knows that it's the Father and the congregants, which will continue talking here in this case. So summarized, if you want to compare, start by making your own test set. That works, obviously, if you're in a niche market. If you offer PBX solutions, like Pascam does, it's a bit harder. Then you need a more generic data set, and maybe you'll have to work with some complaints from customers, see what you do. And if you use Whisper, remember the hidden propaganda. Thank you. Do you have any questions for me?
Thank you, Joachim. Any quick question about speech recognition and Whisper?
Okay.
What is the license? Is it open
What
source?
was it? What?
The license?
The license, the ones on Hugging Face are at the moment cookie license. We might change it. We haven't really decided yet. The problem is we can't move back once we do so. It's non-commercial use.
And also for Whisper?
For Whisper is, I don't know what the license for Whisper is. You can use it for commercial use for sure.
Yeah, a really quick one about the Vanheuverzwijn platform. What kind of ingesting do you have supporting about the audio, and if it's possible to integrate how with SIP networks?
Yes, so we have some plugins like we have plugins for Asterisk, for FreeSwitch. There's some generic scripts. So if it's Vanheuverzwijn is mostly offline transcripts. So we have scripts that can just monitor a directory or a folder for new files that are WAV files, and we'll upload them. We have integration with a couple of commercial PBXs as well. So if somebody wants to integrate with us as well.
Real-time?
For the streaming, we don't have any streaming in the Vanheuverzwijn platform at the moment.
No, I was asking for the on-premise solution. So on-premise solution with some kind.
Yes. So for this, we have modules for Asterisk and FreeSwitch, and a few more. So the server is WebSocket server, and then you just stream the audio there. You get back the results.
Perfect.
Thank you, Joachim, once again for all your work in VoIP.